Good morning, everyone. Welcome to our second session this morning for Net Zero House Building. This is our very first event, so thank you for joining us, and thank you for joining today for this session with Peter Needle from BOSCH. So, hi, Peter. How are you?
Good morning. Good morning.
So, really, we've invited you today to talk about lithium batteries. There's a handful of people in the UK that know a lot about power tools, and you're one of them. So you've been in the industry for 25 years through engineering and sales departments at Hilti, and now with BOSCH Group. So I'm guessing you know your way around power tools, but also the important subject of batteries, and lithium-ion batteries in particular, how they've changed pretty much everything, really, mostly for the good. So really pleased that you could join us today and tell us a little bit more about this subject and what it's doing for BOSCH, but also what it's potentially the opportunity and exciting sustainable future it might help us create. So, hi, Peter.
Thank you for inviting me, and thank you for thinking I'm an expert in power tools. My specialist interest subject is lithium-ion batteries, and it's a complex business. Some great benefits, but also some downsides. And I think if I was going to build a low carbon house, I would want to be fully aware of what lithium can bring to the party. Before we start talking about it, what I wanted to show you is what the BOSCH Group worldwide, with all our factories, what we've managed to achieve in terms of low carbon. From April 2020, that's almost a year ago, BOSCH was the first industrial company to become carbon neutral. So let's play this video to give some ideas of what BOSCH Group is trying to do for the world, and then we'll come back and we'll chat about lithium and how lithium works and how lithium could be integrated into low carbon housing.
Okay, brilliant. Thanks, Peter.
Climate change is not a science fiction. It's a fact, it's happening. And we believe at BOSCH that we have to react. Because in order to limit global warming below 2 degrees by the end of this century, the fossil emissions have to be reduced to zero by 2050 latest. And that's for us the motivation to act now and to put our whole company CO2 neutral by next year. Well, I have a long story regarding this project because 1 week after I became CEO of BOSCH, I asked our central research to come up with a concept for CO2 neutrality of the BOSCH Group. So step by step, we were increasing our activities until today we finally announced complete CO2 neutrality by 2020. We have a strategy to focus on 2 short-term and 2 long-term measures.
It is impossible to radically cut BOSCH emissions right away, but it is possible to neutralize our global annual carbon dioxide emissions of 3.3 million metric tons in the short term. We are focusing on 2 methods. The first method is green energy. That means that we purchase green energy to a much greater proportion than we have it recently in the global energy mix, and we use this green energy from solar or wind parks. Secondly, BOSCH is investing in certified environmental projects to compensate for those carbon dioxide emissions that are unavoidable, for example, in our foundries. Environmental projects means, for example, afforestation in Panama or wind farm projects in the Philippines.
We at BOSCH, we should not leave it with short-term measures only. We should also go for long-term measures.
In the long term, BOSCH will use 2 methods to promote the sustainability of its carbon neutrality program. We will significantly increase the share of energy consumption by renewables. What does it mean? We will expand the renewable energy on our locations, for example, by installing photovoltaics on our roofs. On the other hand, we want to make exclusive long-term supplier contracts with new wind farms and new solar farms all around the world. Without embracing energy efficiency, it is all for nothing. What does it mean? We have to reduce significantly and sustainably the energy consumption of BOSCH. We have a huge portfolio of measures we can use for this. For example, LED lights, change of heat pumps, or also the automatization of building technology. On the bottom line, by 2030, Bosch spends 1 billion euros in the carbon neutrality program.
We at Bosch, we are the first major industrial company to become CO2 neutral. This project does not only have an environmental effect, it also has an effect to stabilize our society. And we hope that other companies will follow our example.
Brilliant, Pete. That was quite an inspiring video there. So obviously there's been massive amount of learning, I guess, within Bosch on how to get to net zero, and especially your knowledge as well within the tool sector and batteries has huge implications for sharing across other sectors. And obviously we're talking about house building today. So yeah, what I guess my first question kick off really is you know, well, what does this mean for your power tools and how the batteries are working now?
So Bosch is a charitable foundation. We don't pay shareholders, so we have a huge advantage in that we can do the right thing for humans and for the planet. We really can do the right thing. We have a lot of cash and we invest it back in the business. And in fact, we've chosen to not only invest it into green products, like washing machines and all the other green things you can think of, but we chose to have a mission statement for the whole company around we want to capture the sun and we want to store it. So that as a huge 700 billion euro company, that's what we're trying to do. Yeah, yes, we sell toasters and washing machines and Worcester Bosch boilers, and we put a lot of stuff into cars, but the profits are being pumped into making photovoltaics better and trying to make batteries better. We have 200 engineers worldwide trying to work on batteries, and our two pillars are sustainable mobility, electric cars, hydrogen fuel cell cars, and sustainable housing. So in sustainable housing, what we're trying to do is put photovoltaics on the roof and store the energy in lithium-ion cells in the cellar, in the kitchen, in the garage, so that you're generating your own electricity. If we can store it, of course, it's not that easy. The company that cracks batteries to store the sun's energy, or to store wind farm energy, or heat exchange energy, they'll be richer than Apple. And it's a complex task. And we've been on it for about 8 years now. We've come a long way. The trickle down is that my power tools have the best batteries on. I can, but it's not what I'm trying to show you today. What I want to talk about is lithium ion, so that if you are building a house, you could set your mind to putting photovoltaics on the roof and figuring out how to put lithium ion storage into the garage, into the kitchen, into the cellar, somewhere, so that the house can be sustainable. So I thought I'd show you lithium ion. I'm going to move this slightly down to one of my grandma's. I'm not sure what this is. It's not silk, but it's very posh. I use this a lot. So let's move you and let's go down and tell me when you can see this cloth.
I can see that. I'm going to turn my camera off so that the screen's bigger, so people can see your screen. There you go. Perfect.
Okay, Nathan, I'm not testing you, but what is that?
It looks like a normal battery, a normal AA battery.
Yes, it's a lithium-ion cell, and
lithium-ion cell. There you go.
There's 3 factories in the world that make this cell, and they are made by the million. I want you to write this down. This is called an 18650. Write that down, Nathan. I don't know if you've got a pen. And I want you to also write down next to it, I want you to write down 3.6 volts. Yep. Now this rechargeable lithium-ion cell is what dominates the landscape on planet Earth. When this first came along about 10 years ago, it was a huge step change above nickel metal hydride and nickel cadmium. You've heard of both of those.
Mhm.
And the reason it was a step change was because lithium ion had twice the energy density. So half the size, half the weight for the same amount of energy out of a cell. Wow. 10 years ago, that was a revolution, and it has taken over the world. You will see this cell in hundreds and hundreds and hundreds of different products. Laptops, e-cigarettes, power tools, all the power tool manufacturers use this cell. You will even see these in electric cars. This is what Tesla use. So all they do, Nathan, is they take this cell, 3.6 volts, and they string cells together to achieve the voltage that they want. So let me show you a power tool cell. You see that?
Yep.
And can you see this top layer is 5 cells?
Yep, I can see that.
So what Bosch Engineering has done is they've taken a 18650 and they've strung them in series, 5 of them in a line. And this top row, 5 times 3.6 volts. You won't be able to do that in your head. You're good, Nathan. I know you've got a maths A level, but you'll not be able to do that in your head. I'm going to help you here. You maybe reach your phone and do 5 times 3.6 volt equals 18 volts. You see, it says 18 volts.
Yep.
Great. So here's my second question, Nathan, because you're a bright young man. Why have I got another battery under here?
When the first lot run out, I suppose.
Yes.
Maybe.
I knew you'd get it. So I've strung another 18 volt battery in parallel. What that actually does, it gives me more runtime. It gives me more distance in the car, or it gives me more holes from the power tool. That makes sense, doesn't it?
Yeah.
So if I wanted to run a house, I would string these cells together until I reached 220 volt, 240 in this country, and then I would string cells underneath, more and more and more and more and more cells, so that when I switch this generator on, I can run more and more lights for a longer period. Make sense?
Yep.
So the more cells I have, the longer my house will run for. The more lights I can have on, the more chance I have of running some heavy appliances like a kettle or a hair dryer. These big wattage tools. Does that make sense?
Yep.
Good. So this is easy, isn't it, Nathan? This is easy. We've got lithium ion and we've got these cells, and all I do is I string these together, and there are a number of manufacturers that will put these refrigerator looking units into your house, and you can store the electricity you make during the day or the electricity you make during a windy day, because you've got a little turbine on the roof, and you can store it. And then at night, when you come home, there's nothing, the wind's died, you can switch all your lights on and you can charge your car and you can run your washing machine just off these cells that you've got in the garage.
Yep.
Sounds like a dream, doesn't it?
Yep.
Now, what's the problem? Why is this hard to do?
The space you'd need is, I guess you'd have quite a lot of those. We'd need a lot of lithium, a lot of units.
Yep. Space, certainly. So a typical domestic unit would be maybe the size of an under-counter fridge.
Okay. Not that big then. So
not that big. Plenty of room for that in the garage.
The cost?
Yes. Now the cost is an interesting thing, isn't it? Because these lithium-ion cells aren't that expensive now. 3 factories make them by the million, because all the manufacturers are using these cells. So the cost isn't that high. So yes, the cost, but certainly you'd have to pay profits to these clever people that are putting these cells together to make them run a house. The real problem here is the chemistry. There's a fatal flaw with lithium ion, even though it is the wonder drug. It's what runs the world's batteries. Nothing would function without lithium-ion batteries now. There is a problem with it, a problem so bad that we dare not speak its name. What's the problem, Nathan?
Would it be what is it? Is it the after effects of it? What you do with it after?
Yes, that's certainly. We don't really fully understand that yet. How do we recycle it safely and ethically? The real problem, and the reason I asked you this question and put you on the spot, is because I wanted my audience to be thinking, what is the problem with lithium ion? It sounds like a dream. The problem is, Nathan, it hates heat.
Right.
If you get these cells to 60 degrees, and that's not really very hot at all. I saw that before we started this seminar, you had a cup of coffee or a cup of tea in your mug, and that cup of tea was hotter than 60 degrees. So if you get these cells warm, what happens is the chemicals inside start to degrade, and you start to lose lifetime on the cells. So year one, you've got your new power tool, you've got your new laptop, you've got your new Tesla car. Year one, the cells are fantastic, ready to go. But every time you get them hot, 60 degrees, you start to lose a little bit of lifetime.
Mm-hmm.
Now, this is appalling because a Tesla car is really pulling some current. A power tool is really pulling current, whereas you try to drill a bigger and a bigger and a bigger, deeper hole, and the drill bit is snatching on the wall of the hole, and that the friction's rising, and the motor needs more energy. Then these cells get hotter and hotter and hotter and degrade. The first problem with our in-garage refrigeration power unit is the cost of it. But the second problem is, well, it doesn't really matter so much about the cost. The problem is, how long will the cells last before they're useless? Will they last 10 years, 12 years, 15 years? If we could get them to 20 years, well, this would start to really cover the cost of the lithium-ion cells because, they've been used every day for 20 years. But the problem is heat. Every time you switch the kettle on, put the lights on, I'm pulling current through here and it starts to warm up. Does that make sense?
Yep.
So I don't know whether you have a Tesla car. A man of your status probably does. When you buy your first electric car, it will come with some really, really clever electronics in it. The electronics in my power tool look a little bit like this.
Mm-hmm.
And these are really, really clever electronics that stop you, or stops my users, my builder, doing stupid stuff and getting this hot. So if my builder pulls too much current, the electronics in a BOSCH drill stops you. So provided you've got expensive electronics running these cells, then it will stop you from doing stupid stuff. I don't know if you know this, but if you take your Tesla to a racetrack and start racing with it at full acceleration, it's an awesome tool. You've heard of the power of the Tesla and how fast it is up to speed, faster than the Ferrari.
Yep.
Well, of course, the Tesla's electronics know that you're really pulling current through the batteries, and after 15 or 20 minutes or so, the car will say, "No, stop it! No, you cannot race like this. No, stop it!" And the car will slow you down, and the car will bring you back down to a speed where the batteries are still within their below 60-degree target level. So lithium is fantastic, but we need to be careful. We need to, as a house builder, we need to understand, A, how much electricity will my occupier, my owner of the house, how much electricity will they save by not pulling it from the grid? And how long will the cells last in the power bank that I buy for the house? And they are better. In fact, I've ordered my first one, Nathan. It's cost me £7,000. I'm not sure I can say that out loud. And for me, it's not actually about will I save £7,000. It's actually about me saving the planet. So for the cautious carbon neutral home builder, he should be thinking about photovoltaics, definitely. He should be thinking about batteries, And his first question is, do I want to save the planet? In which case, get the power bank for the house. My second question is, do I just want to save the homeowner some money? And that's not easy, that. And at the moment, I've invested now because I want to save the planet. I probably over the next 10 years will only just marginally save that £8,000. So as the tech gets better, then power banks in houses will get better. At the moment, they are profitable over a 10-year period, but it has been close. The last 4 years has probably seen that step over the line where suddenly it is worth having them. And it's taken me 4 years to pluck up the courage to spend that money. It could be because I'm not paid very much, Nathan, or it could be that I'm just cautious. But I would urge your customers, I would urge the eco house builder to really, really look at, yes, I can build heavy insulation, and yes, but where's your storage? Where are you going to store your energy? Because if I was buying an eco house, I would want photovoltaics. I would want a windmill. I would want something in the ground 20 meters down, and I would want it all in electricity in my storage cells in the garage so that I can run the house at night for free.
Yeah.
Cool. Any questions, or are we going to open it up to the floor to say, is there any questions from anybody?
No, definitely would like to do that as well. But I mean, I guess first question from me, because we'll hopefully get loads of questions coming in. But how much? I mean, how quickly are these things evolving now? With I've noticed the battery on power tools getting smaller, as well as more efficient. So I mean, if you could make a prediction, what do you think is going to happen in the next 5 years?
Okay, let me bring you back down. Let me bring you back down. Of course, we're ad-libbing a bit. I hadn't planned on this. So here's my 18650. Essentially, on this battery cell, I can pull 800 watts through the motor before the electronics shut it down. The electronics will say, no, you're at your 800 watt limit. I will not let you have any more because you're going to get the cells too hot. I've got a clever thermoplastic coating that wicks the heat out, which helps to keep the cells cool. I've got air corridors down here, and our chargers, when you charge a battery, blow air through these air cells. But Bosch has developed, for the next generation of power tools, a bigger cell. Can you see it slightly bigger? Maybe you can't see from that angle.
Yep, I can see. Yep, width is definitely bigger.
This is called a 21700 and is double the current. So if I'm running at 18 volts still, I've now got a 1600 watt battery. So you can see this battery is with this cell, and this battery's with this cell. So we are already evolving, and that's what all the battery manufacturers are doing. The factories are producing, every day their scientists and engineers are trying to come up with better batteries. And it's a fast march. Now, did you ask me, will lithium ion be the magic bullet that we will go to Mars with? Well, we already are going to Mars with lithium ion. Well, and to be honest with you, when 50% of the cars on the planet are lithium ion, will we suddenly realize, actually, lithium is probably not very good, like we have done with coal over the last 200 years? I would predict that probably we will. And there's all sorts of companies working on salt and air and carbon ion and all sorts of batteries in the hope of coming up with something that works better than lithium. And we will see that race evolve. Would that stop you investing in a lithium power tool, Nathan?
No, I think
no, because they're here now.
Yeah.
So will it stop a house builder investing in a lithium ion power bank for the house? No, it shouldn't, because that's all you've got at the moment. Yeah. Will in 10 years' time you need to change it? Well, probably. I would hope you would, because lithium ion is not the dream. There's got to be better things. So I would say to house builders, don't be scared of the future. Invest now.
Brilliant. Cool. Well, yeah, and it's great to hear Bosch sort of leading the way in terms of that innovation. And I'm sure there's plenty of questions. So should we see if anyone wants to ask a question now?
So yeah, thank you for that, Pete. That was really good. We've had quite a few questions coming in. So just whilst we get Pete's camera back on, hopefully people can hear me. So yeah, we've had a few questions come in on that. I think it's interesting. I'd like to know from house builders watching this, how many of you are building homes with energy storage at the moment? And it'd be interesting to hear that in the chat, perhaps. We'll get in touch with us now, but yeah, and obviously the technology that goes with that in terms of the renewables we need on our roofs and air source heat pumps and so on. So I've got some questions that have come in for Pete. So are you there, Pete?
I'm here.
Brilliant. Do you want? So yes, I've got a question from Max, who's been on this session. So he mentioned about Tesla batteries and how good, well, the lifespan of those batteries, and I guess what the implications for power banks as well.
And so, what was the question, Nathan?
And the lifespan of lithium-ion batteries. What is the typical lifespan for a Tesla battery, for example?
And I fear that some of these questions I just would not know the answer to. What I would say to that is it depends how hard and hot you run the cells. If you're a furious driver who loves a racetrack and those cells are approaching 60 degrees every day, these cells are not going to last as long as the way I drive or my mother-in-law drives. Possibly my Tesla would last 10 years, and Tiff Nadell, my racing driver cousin, would maybe use up the Tesla batteries in maybe 3 years. So the answer is I don't know, but it depends on how hot and hard you run the cells.
Oh, well, I knew I recognised that from somewhere. So, brilliant. Okay, thanks, Pete. And the other question I've got is one about storage underground. What options are there? Is that something you've got any knowledge on in terms of lithium being stored underground as an energy storage?
In terms of of course, in terms of storage after they're used up, so waste storage underground, or in terms of
no, I think for storing energy for a house. So could you, if space, I suppose, is a problem in a house, could it be stored underground?
Absolutely. I mean, my cellar is nice and cool. That has got to be better for the lithium-ion cells in my cellar, which is where they're going to be, because it's cooler down there than it is in my kitchen, with the sun coming in and the kitchen's nice and hot with all other things. So you've got to keep lithium cool, and you've got to inspect your manufacturer of your power banks. How do you keep them cool? What do your electronics look like? And once you get into that kind of conversation, the company that's selling you the power bank will start to go, you know a bit about lithium-ion, do you? Okay, and then they'll start to talk perhaps a little bit technically with you. But any way you can keep these cool, if you're the manufacturer you want to use has got water running through or coolant running through, wow, these cells are really going to last a long time, because they've actually got coolant keeping the cells cool. And the bigger cars, Jag Land Rover and the bigger cars, have got a refrigerant running through running alongside the cells to keep these cells cooled as they're powering the car.
Yeah, brilliant. Okay, so Max has said, yeah, thank you for your answer. So he's also said if the pull of the current is limited on a home battery, then the lifespan could be predicted and guaranteed. So I guess it's about building control systems as well, isn't it?
Yeah, yes, it really is. So on a BOSCH power tool, the battery is limited. The electronics will not let you pull over a certain level of current. In fact, it's 45 amps. And so we are able to guarantee our batteries for 3 years. In practice, I know that our batteries last a lot more than that. I've got batteries out there that are 10 years old, but it still depends on how hard you run the batteries. So yes, the current limiter on all lithium-ion will stop you pulling too much current, but it depends how often you're up close to that limiter, because even at 50 degrees, these are still warm cells. 40 degrees, they're still warm.
Yeah. Cool. So I've got a question here. It might be, I don't know, it might be one you can't answer for commercial reasons, but questions come from Robert. He says, is the Tesla solar roof tile system feasible And are Bosch working with other companies, to develop a solar tile that is aesthetically pleasing and deliverable within the next 2 years, do you think?
Yes and yes.
Yeah.
I don't know about our industrial relationships with Tesla, but I do know our industrial relationships with the German car manufacturers go back for more than 125 years. It was Daimler who first invented the car engine, and it was Bosch that invented the spark that got the car going. So that relationship with BMW, Volkswagen, and Bosch and Mercedes it goes back more than a century. So we are working in partnership with all the car manufacturers to produce electric cars and drivetrains to run electric cars. So yes is the answer.
Brilliant, that's good. And then last one, because I know you've got to rush off, Pete, but Steph has said, she's from Gusto Homes, they install PV as standard on some house types. The energy storage is done via diverting spare power to the hot water cylinder. Alongside that, they offer battery storage as an extra, which is being taken up by customers. So that's
Great, lovely.
Yeah. Excellent. Yes.
Who are they, Nathan? Who are they?
Gusto Homes. So,
Gusto Homes, well done. Well done. You are saving the planet. Excellent.
So if you want to connect with if you want to connect with Pete or anyone from Bosch, you can do so via their profile on this platform. And although Pete's rushing off now to Exeter, he may be able to log in later and talk to people because you can book meetings and you can have a chat on here once you've connected with people. There are other people from the Bosch team as well on here, so as well as all our other exhibitors to chat to. So if you want to carry on the conversation, that would be great. So thank you very much, Pete. I am way more knowledgeable about lithium now than I was before, and I look forward to hearing what Bosch develop and bring to the market over the next few months and years. And yeah, it'd be good to catch up with you again soon.
Yes, and Nathan, just on a personal note, thank you. And Nathan, the planet is burning. Do not buy a Range Rover. Don't do it.
No, I've got a hybrid, and next car will be fully electric. So, but yeah, right. You're right.
Great.
Brilliant.
And yes,
thanks,
we all have to do our thing.
Absolutely, every little bit helps, doesn't it? So, perfect.
Thanks,
Nathan. Thanks, Pete. We'll catch up soon. Cheers.
Well done.
Bye-bye.
Bye-bye.